All right, guys, I want to start off this chapter. It has one new thing that we're going to be adding, but I want to tie it into what we've previously done as well, okay? I actually want to start with the first problem that we did yesterday on Venn diagrams, and that was this. So I wrote it up here, that if you have 50 students, 18 of which are in choir, 26 are in band, and 2 are in both, then the question was, how many students took neither? Or neither choir nor band. Okay. Well, I don't remember if I let y'all just kind of try the problem first before we put them here in this concrete picture, but a tendency of people to do this problem is they would say, oh, I'm going to take 18 and I'm going to add the 26 students to it and I'm going to get 44. So that means 50 minus 44 is the 6 students that took neither. And that is wrong, because if you add the 18 plus you add the 26, we discussed yesterday that what problem has that caused? The 2 got counted twice. So that 2 getting counted twice makes it such that this formula where you straight up just add A and B together kind of misses some of what the problem is saying. Well, if you would like to not have to think about things in that Venn diagram all the time, you could use a formula. If you're a person who likes the formulas, here is the general formula that would work. And that would be where you add the probability of A plus the probability of B. So the choir plus the band. But look, here's what makes it different. You take away one little piece that did get double counted. So you would add the 18 plus the 26 and take away a section that got double counted. That would then give you the correct answer of 42, so therefore 8 of them took neither. Okay, so that was just kind of a connection of yesterday's to today's, and as far as doing the formulas go. All right, now let's talk about what happens in chapter 14 when we had 2 events happening at the same time, like this. What's the probability of getting heads on 2 flips of the coin? So you get heads on this flip and you get heads on this second flip. Good? We talked about that, so we're multiplying. Half times a half. All right, and that works great, because the fact that you got heads on the first one does not affect the probability of you getting heads on the second one. Hence, they were what? They were independent. Very good. All right. Chapter 15 is about all of these kinds of problems that are not disjoint, like up above here, not disjoint, so we had to have this special formula here, and finding the probability of A and B when they are not this nice little tidy independent type of problems. Because when they were nice and tidy and independent, you just multiplied the probability of one thing times the probability of other. But we don't have that, because the fact that you are one thing is going to change the probability of the other happening. So here is how that will get done. All right, so we start with the probability of A and B is then we're going to be saying what's the probability of A given that, you'll need probability of A given that, and so that line is red given that. Okay, so that line is the given that. And so what that means is, given that B has happened, so I am not looking at everything anymore. I am only saying, okay, given that B has happened, so out of the B portion of things, what is that section? That is the A and the B together, and that is here. Okay, and then to do the A and B, you would multiply the A times that set there. Okay, so we're going to be dealing with this formula, and I want to demonstrate that here in with more concrete down here in these problems below. So let's go ahead and take a look at those. All right, first of all, I typoed on this, so let's fix the typo before we get going. A should read, what's the probability that a randomly chosen student is a boy enrolled in Spanish? Okay? And I want us to think about what statement B says before we start calculating. Statement B says, what's the probability that a boy is enrolled in Spanish? So I want to give you some major awakening that A and B are calculated differently. So let's look at the difference between them. A, again, says, what's the probability that a randomly chosen student is a boy enrolled in Spanish? Versus, what's the probability that a boy is enrolled in Spanish? What's the difference in those two? Yes, the denominator. What it is out of is the difference. Okay? In this first one, all of the students is the denominator. It's chosen randomly out of the students. But in this second one, I am indicating to you this is a boy. I'm giving you information out of the boys. What proportion of them are enrolled in Spanish? That's the difference. So let's look at that mathematically. Here we go. A is just out of all students. So that's going to be out of the 100% of students. Who are the boy Spanish ones? The 0.2. All right, so this one is a straight up just boy and Spanish. Okay, and these are in percentages, by the way, like 100% of the students, and then this is 20%. All right, but B looks like this. What is the probability that a boy is enrolled in Spanish? The shortcut version of this says, what's the probability, or the way you would notate this, that a student is enrolled in Spanish given that you know it is a boy? Okay? And that's what makes this different. It's now not out of all students, it's out of the boys. So this looks like this. You have the boy probability as your denominator, because it's out of all the probability of getting a boy. And then on top is both Spanish and boy overall. This one's just plain Spanish and boy, which means out of the total. Okay, but this one's Spanish given that it's a boy. Okay, so what is this number that represents the probability of being a boy? Yes, you are now looking at this line here, and so this boy section is a 40% chance, is 40% of the total. So out of the 40% in the bag that are the boys, I want to know what portion of that boy bag is Spanish. And that is the 0.2, so the boy and Spanish. So therefore, 50% chance of getting a person in a Spanish class if you tell me it's a boy. But overall, there's just a 20% chance of getting a boy Spanish if I pull from everybody. Okay, so let me say that one more time. If I pull from everybody, if I have everybody in my big bag, there's a 20% chance I get a Spanish boy, a boy that's enrolled in Spanish. Okay? But on part B, if I have now made my bag smaller to where it only contains boys, so now just out of the boys, what portion of those are the Spanish? And that would be 50% chance now. Okay? So has the fact that it's a boy changed the probability of it being a Spanish-speaking boy? Yes, it has, okay? All right, next, let's see if you can catch the way this wording goes. What's the probability that a student that is enrolled in Spanish is a boy? Yes. So how would the shortcut of that look, though? What have you been given? What information have you been given? Okay, good. You have been given that it is a person enrolled in Spanish. And then you're wanting to know what's the probability they're in a boy. So that means the bag that you are looking at is a bag full of just those in the Spanish class. And of those in the Spanish class, what proportion of them are boys? So we have a different section we're looking at. We're not looking at this boys section anymore. We're looking at the Spanish section. This is still conditional, yeah, because conditional upon me now just looking at the Spanish bag. All right, so what is this amount? My Spanish portion is the 0.5. And what's the boy part of that? 0.2. So that is 40%. So we had 3 different answers based on 3 different subtleties in the wording. So I'm trying to teach you that language that you really need to kind of separate out, okay? All right, let's go to the assignment, and I want to walk you through a couple of those. All right, so on page 15, which you're going to do, but I'm not going to go over any of this with you. This is the Venn diagram stuff, so you'll get 3 more practices on that. Or you could do the formulas if you wanted to, you know, the P of A plus P of B minus P of A and B. All right, so you can do that already. So let's start on the next page, on page 16, and let's do this, some of these card problems together. Because this is conditional, but it doesn't have a table. Okay, it doesn't have a table that's already in probabilities. So let's take a look at that. All right. So the first one says, we have a standard deck of cards, 52 cards. What's the probability that the card is a heart given that it is a red? So I'm going to write out the shortcut. Okay, so that means out of all the red probability, find the probability of heart and red. Okay, I'm going to do this real technical right now, and then I'm going to kind of show you a simpler way. So, a way to kind of streamline it. So, what's the probability of getting a red card when you draw from the deck? 50%, because it's 26 out of 52. So that's half. Okay? What's the probability of getting a red heart out of the deck? A fourth of the deck, because it's 13 out of 52. Okay? So what happens is, how are you going to get rid of this bottom part, fraction? You're multiplying by the reciprocal, basically. Okay? So we're going to do our regular, you know how we do this, 13 over 52 times the reciprocal of the bottom. That's how you do your division. And because those are both out of 52, this problem could have really been thought of from the beginning this way. There's 26 red in the deck, and there's 13 red hearts in the deck. And so the probability of getting a heart, given that it is red, is 50%, okay? So I wanted to take you through the technicalities of the math here so that you see how it's actually really correct. But you can jump to this line of thinking if it's all out of the whole deck anyway. Yes? Yes, you could have done it as a decimal. You could have also done this way, a fourth over a half, okay? And again, that's also going to simplify to a half, okay? So there's several different ways that you can think of it, okay? All right. Next, let's start thinking of these in a simple way now, not like all this bunches of fraction stuff, okay? So here we go. Probability that the card, not the car, is red, given that it is a heart. Okay, now you know this instinctively. What is it? What's the probability it's a red, given that it's a heart? 100% chance, okay? So instinctively you know that. I want to take you through the math real quick and just kind of prove it to you. So out of the 13 hearts, how many of them are red hearts? All 13. So that is why that is 100%. Okay? I want you to try C right now because I have a feeling that you could fall for a little glitch, which is going to teach you something from it. So let's see how you do. There are 4 aces in a deck, 1 from each suit. Okay, so a spade, a club, a heart, and a diamond. All right, let's see how you did. How many reds are in the deck? What number's on top here? You should have the intersection of ace and red on top. Not all aces, but just the red aces, which is 2. Ah, okay. It is 2. It is 2. Okay. Okay. I was trying to see if anybody would say 4, but nobody was wanting to say. Y'all were all right. Okay, good. That's great. Okay. This last one is not really a tricky, except for that you do need to know that as far as face cards goes, that's not the aces. The face cards are the jacks, queens, and kings only, so do that one. And I just left these in fractions because it was easier and I didn't have to do the percentages if I didn't know it. Okay. So, okay. Now, 5, you need to pay attention to, how many are males and females in total, all that stuff up there. But I have had students have difficulty reading the next table, the table on the next page. So let me just make sure you can follow how to read that, and then I'll let you work. All right. So on this problem, this is about adult American men and those that they sampled and the proportion of them that had high blood pressure, high cholesterol, or they were okay blood pressure, or they were okay on their cholesterol. So, in other words, this means 11% of the American men had both high blood pressure and high cholesterol. These 21% here would have what? High cholesterol, but okay blood pressure. All right? That's how you read that. And then statement C, I just wanted to kind of put this here to let you know that it's not just an easy peasy quick little blip out a number problem from the table. It actually is a given that scenario. Okay? So keep that in mind as you read through that and do it. Okay, you're going to finish this up and then I'm going to come and stamp you for everything before you go on break.